All right, welcome everybody to the BioC 2021. This is a long workshop on building carpentries-based bioconductor lessons. I am Jenny Drnevich. I will be kind of the main lead of the workshop. But first, again, you should be familiar with this. If you have any questions, you can put them in the conversation tab. Either you can do the formal Q&A, and then we can see those, and those can be put up onto the screen. There's also the general chat that you can use to discuss things. If you want to talk, you can raise your hand and we can bring you up on stage. And there's emoticons if you want to give the feedback. If you need to leave early, video of this will be available a couple hours after the session. Okay, so that's that. Now let me share my screen. And the one that I want is this one. Okay, so this workshop is going to be run a little bit differently. While we do have the orchestra platform, we're not actually going to be launching that. We're not going to be doing anything inside our studio today. We're going to be doing it all on Git. But welcome on behalf of the Bioconductor Teaching Committee. I'm going to move to the first vignette, which is the building carpentries-based bioconductor lessons. Oh, let me put the link of here into the chat. My way. All right, so that will take you to this page, and this is the page we're going to be mainly using during the workshop here. So I can go to the first lesson, and so with me today from the teaching committee are Charlotte Soneson, Laurent Gatto, and Kevin Ruel-Brecht. I guess Robert Costello is not here. And Toby Hodges is our liaison with the Carpentries. So we wanted to just give you an update of what the teaching committee has been doing in the last year in terms of our goal of creating 3 different workshops, what we have built on the Carpentries principles. And so if you're not familiar with the Carpentries, this is a worldwide organization to teach coding skills in a very sound pedagogical method. And so we've been working with them, and Toby has been training us over the last year. And so we want to show you what we have right now, and we want to get feedback from you and help get contributions to developing the lessons. This is a workshop in itself, so therefore we have tried to apply the Carpentries principles to this workshop, including, so the prerequisites for people is just if you need to know basic knowledge of R syntax and you have an interest of teaching R to others. Now, a lot of stuff we're going to be doing is in Git. So if you know Git, that's better, but if you don't know Git, you can still contribute and you can still be acknowledged for what you do. The whole Carpentries, what they have put together about teaching technology and the research they've done and how best to train people in technology is really excellent. So I really would point you to these background readings if you do a lot of training and teaching other people. So what we expect with you today, hopefully we'll help you look over the lesson materials that we've planned, and then we're going to break out into the tables and do a lesson sprint so people can contribute ideas, suggestions for improvements. Particularly, Toby's going to talk about how to do evaluation tests and how to best formulate these so that they actually can test and assess what your learners have been learning or where they've been having trouble. Reminder that we're going to follow the code of conduct that's been set up for the conference. So, and this is aimed to provide a supportive, collegial, and harassment-free environment. If there's any issues, please let us know and or through any of the avenues outlaid in the code of conduct. Okay, so I've done pretty good about my 5-minute introduction. So the workshop goals and objectives. We're going to describe the backward design instructional model. We're going to assess the introduction, well, actually probably all 3. Some of us will do each one. And then we want, hopefully by the end of this, you'll understand how to create a meaningful assessment exercises to test whether the learners have learned a particular skill or concept. The learning objectives, what we want to do is mainly to modify and edit the workshop materials, ideally to create multiple choice, fill in the blanks, minimal fixes. And then from this, hopefully you can get to networking. If you're interested in joining the education committee, we would welcome you, and or doing finding other people that you might be interested in developing other lessons. So let's move on to the next section for the Carpentries Guiding Principles. Again, this background reading, they have this very wonderful long chapter about all their guiding principles from the Carpentries. But today what we're going to focus on is the design and writing exercises. And let me stop sharing my screen. And Toby is going to come on to give that section.
Thanks, Jenny. Let's see if I can find the appropriate screen window to share. That's good. And there we go. First of all, I'll ask, I suspect I am the person in this session who uses R Markdown and slides created from R Markdown the least, so please bear with me while I'm running through these. I'm the curriculum team lead at the Carpentries, so I'm a member of the Carpentries core team, and I'm working with primarily with members of our community who are developing lessons, either maintaining some of our existing official lessons or working on lessons like the 3 Bioconductor lessons you'll hear about today that are being developed in a place called the Carpentries Incubator, a space that we've set up for members of our community to collaboratively develop lessons together. Jenny already mentioned the Carpentries is a US-based not-for-profit organization, and we're aiming to build global capacity in essential data and computational skills for research. I already mentioned the incubator, but you can check that space out if you want to learn more about some of the other lessons that are being developed there as well. Or perhaps you want to propose to create your own. So the aim of this presentation, as Jenny already mentioned, is really to get you all thinking about how to design good exercises that are appropriate to the audience for the lesson and the topic of the lesson. And towards the end, I'll show you a little bit about how to format those exercises to be rendered correctly within the Carpentries lesson template. But I think that for a workshop such as this, I think this part of formatting those exercises correctly to render nicely in the web pages is secondary. I think the time today could be better spent trying to collect some good ideas for exercises and not worrying too much about getting them exactly looking right in the rendered pages through GitHub Pages itself. So it's going to be most relevant for any lesson where there's a clear idea of who the target audience is and already some defined learning objectives, some defined sort of outcomes that you want to have from the lesson and from the individual sections of the lesson. I think you'll hear more about the work that's been done towards these 2 points for each of the 3 lessons later on. And so to jump ahead a little bit, the goal, if you have those objectives already defined for your learners, is to design at least one exercise that assesses the learner's progress towards those defined objectives. The reason for that is that if you have at least one exercise for each of these objectives, you can use them during a workshop in formative assessment. So the opportunity to find out, to measure how much progress the learners have made towards these particular individual objectives for your lesson while they're still in the lesson, while they're still in the workshop, and while you still have the chance to react to the outcome of those assessments during the workshop itself. And so the idea is that if these exercises have been designed well, then they will tell you whether the learner has learned the thing that you intended to teach them, and also beyond that, whether if they haven't learned it or if they've misunderstood something, what the misconception is, so that you can as quickly as possible address it and fix it during the workshop itself. So, for example, if your lesson had the objective that you want your learners to learn how to add additional gene annotations to an object, that's one of the objectives taken from one of the lessons we'll talk about today, then an appropriate exercise to assess progress towards that objective could be asking them to fill in the blanks in a code block to add a vector as a new annotation to a summarized experiment object, as shown here. And then these underscore symbols in the code block itself are intended to indicate the blank spaces that the learner would need to fill in. I'll talk a little bit more about these kinds of fill in the blanks exercises a little later on, I think. So I already mentioned that the idea with these exercises is that they should help you and also your learners assess whether they've learned what you've just tried to teach them. The reason that I mentioned the learner here as well and that kind of self-assessment is that increasingly what we see is that because our lesson materials are developed in the open and published openly online, a lot of people are visiting those pages to work through the materials on their own and not in a workshop setting. And so, again, that's another thing to think about when designing these exercises, and in particular, it's why it's so important to make sure that you include a solution block with all of your exercises as well as the exercise question itself. They should be specific to the target learning objective. So the idea is that you have this one-to-one relationship between an exercise and the specific objective it's intended to assess, and not a larger exercise that spans more than one of those objectives, more than one skill that you're trying to teach them or concept that you're trying to help them understand at any one time. In my opinion, it's sort of okay to include larger exercises that cover more than one of these things, as long as you also have the smaller exercises beforehand that are specific to the particular objectives. And ideally, as I already suggested, the incorrect answers should have some kind of diagnostic power. And so the idea with having blanks in a fill in the blanks exercise, for example, or having multiple answers that you can choose between in a multiple choice question, is that the ways in which they could answer it wrong can also tell you something about what they have misunderstood or in what way they have misunderstood what it was that you were teaching them, because that allows you to much more efficiently and effectively fix that misconception if you're teaching in a workshop. And also it gives you some other information. For example, if you've got a group of, say, 20 learners in your workshop and each of them seems to answer this in a completely different way, and you get kind of an even spread of the incorrect answers, then that probably tells you you need to repeat the entire thing because people just kind of didn't get it. Whereas if one or two people were making the same kind of mistake, then maybe you can just more quickly go over a subsection of the part that you were just teaching. And lastly, you should aim to spread the exercises out through the material roughly one every 10 to 15 minutes. This matches up with the sort of attention span, and also it helps to ensure that your learners aren't getting too overwhelmed with too much new information all at once before they have a chance to use an exercise as an opportunity to apply that new knowledge that they've just gained, which helps them transfer that knowledge from the kind of working memory, which is very limited in space in our brains, and the longer term memory, which is much, much less limited. So in the next section, I'm going to go through a few examples of some different formats that might be suitable for exercises for lessons on bioconductor topics. These are examples that are taken from Greg Wilson's book, Teaching Tech Together, that Jenny mentioned in the introduction as well, and that I highly recommend checking out. there is a whole chapter in that book that's devoted to different formats for exercises, and it covers a lot more options than I had space for in this presentation. So first of all, the sort of tried and faithful multiple choice question format, which can have a bad reputation. I think that it's very easy to write not helpful multiple choice questions and quite challenging to write ones that are well designed and actually useful in terms of providing that diagnostic information from incorrect answers, for example. And so you can see the example here. There's a question, and then underneath there are 4 different options for what the answer could be. But what I really want to make sure that you recognize here is that, at least at first glance, it is very hard to tell if any of those incorrect answers are definitely wrong, unless you're an expert in the topic already. So there are no joke answers in here, no answers that are amusingly obviously wrong, I suppose. Instead, the idea is that each of the incorrect answers here should be what is called a plausible distractor. So it should require the learner to stop and actually consider each of the possible answers before they are certain that they've chosen the one that they think is right. And beyond that, each of those plausible distractors, the ones that are incorrect in the answer options, should be giving you as the instructor some information about what it is that they've misunderstood about the about what you've taught them that's being tested with this exercise. The next example that's also really popular, I think, as an exercise format is code and run. So giving the learner a challenge of something to write some code to achieve, and to run that to check that it works. And you might give them the expected output, for example, and ask them to write the code that creates that output. I think the reason that I've included this so high up the list is because I want to really strongly encourage you to be careful about choosing this as an exercise format. For any lesson that is designed to be taught to novices, to people who are really just getting to grips with Bioconductor or perhaps with R itself as a language, it's really, really easy to make these kinds of code and run exercises too difficult for those novices. The reason for that is that they're still really getting to grips with so many things, like new concepts and new skills around learning the language and learning the whole Bioconductor ecosystem, that being presented with a completely blank page from which to try to write something new from scratch is it's really challenging in terms of the kind of cognitive load that places on the learner to try to remember all of the moving parts and how they need to fit together. So instead, what I recommend is that you try to introduce some additional structure to these kinds of questions to help support those novices a little bit more in focusing on only the specific things, the specific skills or concepts that you're aiming to assess with this particular exercise. So, for example, you could combine a code and run exercise such as this with the multiple choice format that we showed before to give different possible answer options, so that then they need to look at pre-written answers and choose which one is the right one to solve the problem, rather than having to write it all themselves from scratch. Hey,
Toby, we had
yes.
One question. I don't know if you can see this, kind of about the multiple choice.
I cannot.
Okay, the question is there a particular value to using none of the above in your mind?
I think that in some cases using none of the above can be helpful, because it's still, what's the word I'm looking for? The learner still needs to engage with that answer in a way that perhaps forces them to really consider all of the other answers as well, to to make sure that they're sure if they're choosing one of the ones that isn't the none of the above or the all of the above perhaps option as well. But I think that actually it's not as powerful as in terms of like diagnosis as the other more specific answers, because if someone says none of the above, it doesn't really tell you why they don't think that any of those are right. Whereas if they choose one of the top three, then you know what they think is the way that this works, and you can correct them on the order if they didn't get the order of evaluation right in this case. So I don't think that they are bad to use as answers, but I think that you would want to be sure that in this specific case, it's helpful, and that you're not only putting it there to try to trick people or something, or to make up the numbers to 4. A lot of people feel that it's necessary to include 4 different options to a multiple choice question, and I don't think that you need to do that. If you can only think of 3, where 2 are plausible distractors with diagnostic power, then that's fine. I hope I answered the question. So the next format would be something called minimal fix. This provides some more structure in terms of code that's already been written, and works to help learners develop those debugging skills that are really essential for someone to learn to become independent when writing code. The indentation on these lines has gone strange, but it's Python and not R anyway, so it's perhaps not a great example for this audience. Sorry about that. The idea here is that you're asking people to identify where in the example code block something is going wrong, and asking them to make the smallest possible change that they can think of to fix it to behave correctly. And yeah, so this would then require them to be able to trace the execution of the code and figure out where the problem is occurring, but it also requires them to engage with this idea of what is the minimal fix, what is the one small change that they can make to fix the code, rather than changing 6 things in 5 different places, for example. Another one kind of similar to this is the theme and variations format, where you provide some pre-written code again, but in this case you're asking them to adapt, to modify that pre-existing code to change the behavior slightly. So in this case, we're asking them to change the inner loop of the function so that it fills an upper left triangle with a particular color, instead of filling the entire triangle. And this, in my opinion, is extremely valuable as an exercise format for people who are first learning to code, or first learning to do things with a new library, for example, because it teaches them how to adapt existing code for another purpose. And that's, whether we realize it or not, what a lot of us are doing on a near daily basis when we look for an answer to a question that we have about how to achieve something online, or in the documentation, in examples in documentation pages, or on Stack Overflow or something like that, for example. And then we adapt that answer to fit our particular circumstances, because it's very unlikely that the example in the docs or on Stack Overflow is exactly what it is that we're trying to achieve in that case. And another one that's a little bit more like one step removed from writing the actual code, but that can be really useful to assess a learner's mental model of the topic or a subtopic that you're teaching them, is to ask them to label a diagram. This works particularly well in a workshop where you have a whiteboard or something that you can draw things out on, or you can share printouts of a unlabeled diagram to people, and ask them to apply the labels that you give them in the appropriate places on that diagram, for example. And I'm sure that there are online tools that you can use that maybe you're aware of already to achieve this kind of labeling of a diagram exercise as well in an online setting. And then last but not least here is the Parsons problem, which is where you give all of the lines of code that are required to achieve a particular task, but in the wrong order, perhaps without indentation. And if you want to make it particularly challenging, you can also add additional lines that are not actually needed and tell them that they might need to leave some out of their code to get it to work. And then that then asks the learner to reorganize these to get the program working in the way that it's intended to. And as it's written here in the notes, it's particularly well suited for testing understanding of control flow and testing understanding of the kind of structure and perhaps scope of a script or a block of code as well. Different types of exercise in these different formats I've gone through a few examples of now are suited to assess different skills and to assess different levels of experience as well. So, for example, the fill in the blanks exercise is a really good fit for novices because it provides that structure of most of the code already. It avoids the kind of blank page fear that can come for novices, and it gets them to focus specifically on the particular concept or the skill that you're assessing. By pre-writing everything else that you're not assessing right now, you make sure that you're focusing in on assessing that understanding that they have of the particular thing that you're working on right now. Things like the minimal fix exercises are less well suited to novices because tracing the execution of a program, identifying the problems that are there in it, thinking about all the different ways that it could be fixed and choosing which one of those is the minimal fix, and then actually implementing that fix correctly is it's a whole bunch of things to ask a novice to do all at once. And for example, in workshops where we've been teaching novices, I've encountered on quite a few occasions learners who have run into trouble with their code and have been able to tell me where the problem is, perhaps assisted by the information that they get from an error message, for example, and what they think is the thing that needs to be fixed, but they can't write the correct syntax to actually fix it. And the more that they try to do that, the more what's actually wrong with the code changes, and they can very quickly reach the point where they're despairing altogether by the time we come to their desk and actually try to help them. So I guess the summary of this is that if you're working on a lesson that's aimed at novices, try to go for these exercise formats that provide more pre-existing structure and really define quite a small scope of exactly what it is that you want the learner to do. If you're working with more sort of what we refer to as competent practitioner learners, people who already understand the basics and have learned the strategies for debugging and trying things out and testing to figure out where exactly the problem is and so on, then some of these more advanced kinds of formats like minimal fix will work a little better. I've said already, but try to align the exercises with the specific learning objectives. If the objectives that are defined for your lesson or for this particular section of your lesson use skill kind of verbs, action verbs, try to think about what an exercise would be that would require the learner to actually do that verb to be able to solve the exercise, and that's generally a good guide. Mix up these different formats where you can. I think having variety there is helpful and keeps things more engaging. Plenty of scaffold for novices, as I've already said, and always include a solution to your exercise. So within the Carpentries lesson template itself, exercise blocks are created as special markdown block quotes in the source markdown file or R markdown file, followed by this curly brace, colon, space, dot challenge, closing curly brace. The space at the end here I think is not necessary, but is usually there for readability purposes. And what that does is it assigns this challenge CSS class to the preceding block in the rendered web page. Let's take a look at an example of that. Hopefully you can see this if I switch over, and I'll copy and paste this URL into the chat once I've stopped sharing my screen as well. This is a page from the documentation for our lesson template that describes how the R Markdown source files are rendered into, are written and then rendered into web pages. And if we scroll down on this page through some of the other details, we'll reach an example of a exercise in the template. So you can see these greater than symbols here mean that this is a block quote in Markdown, or in R Markdown in this case. It starts with a second level heading, giving the title of the exercise, then the body of the exercise with a code block here, followed by the solution box, which is a block quote again, and this is where things get confusing. So now you've got two levels of block quote with another second level heading saying solution, and the code block underneath that will be shown inside that solution box. Then at the end of the solution box, you've got one of these CSS class tags that I mentioned. This one is for the solution class. And then after that first block quote gets closed, you've got the CSS tag for the exercise block itself. And then what that gets rendered into then is the heading here, the body of the exercise here and here, and then this expandable solution box, which if we click here, shows this second code block underneath. So that's what it ends up looking like. Just describing this reminds me of how many things there are to think about in order to format one of these to render correctly. I want to say two things. First, a reminder of what I said at the beginning, which is that I don't think trying to get these to render perfectly should be the focus of this workshop. And I'm very happy to help you if you get stuck with any of this. And the second thing to say is that we are currently in the process of complete redesign of the lesson template to make things like this easier to do, in kind of recognition of the fact that it's a lot to think about to try to get a challenge box like this to render correctly in our lesson template. So I'll share the URL to that page after I finish presenting, which is, by the looks of it, in 2 slides' time. Things to watch out for then, the level of the block quote. As I mentioned, the solution boxes are supposed to be 2 block quote markers deep, and the level of the exercise heading, these should be an H2 heading, which means 2 of these hash symbols before the text of the heading in Markdown. Strange things are liable to happen if you get either one of these things wrong, I'm afraid. So then last, but certainly not least, resources and support for working with this in this workshop and also beyond. The template documentation that I just showed you a page from and that I'll paste the link to in the chat. The source code for that site, because that site itself is built with the lesson template, and so it's a good way to compare source files with the rendered content in that case as well. Questions and bug reports, however, should be made to a different repository, this third URL shown here, that we call the styles repository. And failing any and all of those, please feel free to get in touch with me by email. I'm at Toby Hodges, all one word, at carpentries.org. That is all I had to say. I'll stop sharing and see if there are any more questions.
Great. Thank you, Toby. There was one in the chat. If you want to answer that possibly while I'm getting my screen back up.
Hugo, this will change at some point, right, to using these fenced divs, I think is what it's called. Yeah, that's part of that's the idea for part of the new version of the lesson templates, which I hope will be under a beta release pretty soon. So keep an eye out for that if you're interested to test it out. And yeah, I'll pop the URL in the chat now. Thanks.
Yeah. Okay. So we are now back on this one and go. So we're gonna just each of the rest of the committee here is going to give just a short little 2-minute talk about overview of the workshops that are in development. And so I guess, Laurent, you're going to go first. I'll just keep my screen up.
Okay. So the first lesson that we are developing is an introduction to data analysis. Sorry, can you hear me? Because I think I have connection problems. Yeah, okay. So it's an introduction to data analysis with R and Bioconductor. And so the idea really is to mimic what is already available, the Carpentries lessons that are already available and that are targeted towards ecology. That's at least the lesson I know most as an introductory lesson for R. And revamp that lesson, but to give it a Bioconductor flavor. So the biggest change would be to replace the surveys data. That is really helpful. It's a really great data set to teach, but it doesn't really apply to the Bioconductor type of analysis or type of data that we have. And so we have, or Jenny has identified another data set that we can take as a replacement to that ecological data set, and then kind of rewrite, update that lesson to fit the kind of data sets that we're interested in. And the goal really is to teach people to familiarize themselves with R and R Studio, manipulate data, visualize data using the tidyverse, as in existing Carpentries lessons, and then bring them to the point where they are familiar with summarize experiments, or at least the content of the summarize experiment, and then the structure of a summarize experiment, so that at the end of that lesson, they know R, they know how to manipulate data, how to visualize data, and then they have familiarity with the main data structure that they will need for the next lesson, where they are really going to analyze RNA sequencing data.
Okay, thank you. The next is, so like I said, to point out to this is that with the Carpentries, there are many different introduction to R lessons. And so how you're learning, where the area that you're coming in from, they do not have one for, you know, Bioconductor type stuff. So that was the goal of doing that one. We did also then want to do an introductory lesson about the overview of the Bioconductor project. And so Kevin is going to talk about that.
Yeah. Okay, so if you can all hear me. So yeah, once you've entered the world of R, so Bioconductor adds, so we're all familiar with the CRAN packages, and this is usually your first entry point to R. And so Bioconductor is a project in itself that I guess a lot of us got familiar with, or certain aspects of it. So what the second Carpentries lesson is more about introducing the Bioconductor project sort of in its entirety, with episodes teaching how to navigate the website and find things that maybe even some of us haven't come across yet. So it's easy to focus on the package aspect of Bioconductor, which is one large aspect of it, but also learning to navigate the teaching resources on the Bioconductor website, the supports, where to find help, so the support website. But yes, of course, obviously, how to install Bioconductor itself, the packages, and beyond that, learning that there are vignettes. So every package in Bioconductor comes with vignettes, so learning how to open those and how they're meant to be used. And then one of the strengths of Bioconductor are the common classes and methods that are used throughout the project, so which makes the entire project interoperable. So packages can interoperate with each other because they share the same currency through common classes. So this is what the lesson at the moment is presenting. So essentially we have episodes about an introduction to Bioconductor, Instinct Bioconductor, where to get help, and the standard Bioconductor classes. So the lesson is really about going one step beyond just using R, but learning how to use Bioconductor as a project rather than individual packages. So yeah, and the last thing also is how to contribute, to modify code and contribute to existing Bioconductor packages. So very often you'll see that once you get familiar with the project, you won't just, you will turn from a user to a developer, maybe not developing your own package, but maybe you'll be using a package and you say, I found a bug and I'm actually looking at the code and I know how to fix it. So rather than rely on the developer to do it for you, you can actually get involved in the project. And that is a very, very good step toward being a developer yourself.
Okay. And then the last one, and this is not an introductory lesson, this is more of a second level intermediate lesson that Charlotte's going to talk about.
Yes, so the RNA-seq lesson kind of assumes that the learners have followed something like the introduction to R or the introduction to data analysis with R that Laurent mentioned. And we kind of hope to cover conceptual knowledge underlying RNA-seq data analysis rather than like just providing a workflow, so to say. So it will build on the summarized experiment introduction, and we will kind of we will talk about things like modeling in general, experimental design, what to think about, practice some of that, testing, adding gene annotations, gene set testing. So like the different concepts that help you to understand what actually happens when you do differential expression analysis with RNA-seq with Bioconductor.
Okay.
There's a question in the Q&A for the first lesson.
Okay.
There is a question. Oh, yeah.
Yes. So, Laurent, do you want to take this one?
I think that could be. I think that would be a very good idea. Although that could be an additional episode or maybe another lesson. Maybe another episode to the RNA sequencing lesson that we have. I don't have any firm opinion, but I think that's certainly a really good idea that we should discuss. So maybe Hugo, if you want to join in and contribute something like that.
Yeah. Okay. Yeah, I know there's going to be another workshop later about the tidy summarized experiment and stuff. I'm looking forward to that as well. Although I must say, the pull of the tidyverse gets stronger, although I still kind of resist, but it is quite good. Okay, so what we want to let's move on to what we're going to do today, and hopefully we'll break out. And so how do we contribute? If you're interested in helping us today or in the future, how can you contribute to the development of these lessons? So these are following the open source model where all contributions are welcomed and acknowledged. What we had planned to do today is, so view one of the current lessons, and if you follow any of these links, they will take you to the produced site. So this is what, when you're teaching with learners, this is what they're going to be walking through. This can then also be just available online, as Toby said, that people can just walk through them on their own. And so there's a lot of stuff. These aren't quite perhaps as fully fleshed out as we hoped. Everyone's busy with other work. But we have stuff, and so we have the schedule and the general stuff, and so you can go to and see what we have here. So that's the current lessons. And then what you can do is, once you've identified something or found a typo, is then you can go to the Git page that is behind the forward focus page. And so here's an example of the Git page for the BioC intro. Make this a little bigger, but you'll be looking at it on your own. If you do not know Git at all, you don't have to worry about that part of it. You can still contribute even if you don't know much about Git. And so the main part of what you would do is you can go to the Issues tab. You would need to create a Git account It's a free account if you do not already have one to open an issue. I would suggest, even if you don't know anything about Git, to create a free Git account, and then you can pop up a new issue and just tell us something. Here's my idea, I think it could fit here, and that's the minimal way. You don't have to worry about the formatting and the Git and all that sort of stuff. You just give us feedback this way, then we can track it and we know who it came from, so we can give you proper attribution. Okay, so what we're going to do, we thought that we have some tables set up in the lounge for each of these 3 projects, and we thought we would probably mostly end, but we'll pause right now in a little bit here, and then go split off the tables for the rest of the time to kind of work if people are in one of these particular areas and want to work to see what we have there. Before we end though, I'll just want to keep some last little bits. So if you want more information on the Education Teaching Committee and what we do and how you can join us, we're going to have a short talk that's in the Education and Framework session that's later today. It's going to be at 8 p.m. Eastern time. And then keep contributing. So these are ongoing, they're not ready to go. We still need to do a lot of development. Contributions on GitHub are welcome at any time. If you want to get more on the Slack channel, where there's an education and training section in the Bioconductor Slack channel, in that, let me see if I can just pull this up real quick. Probably not on here because I don't have the Slack going on. At the top of it, there's some pinned documents. You can, if you're in Slack, you can just see what's pinned up there. We have a Google Doc that tells you how to get on. Where's the Google Doc? It is right here. That we keep them the minutes of our monthly meetings that we have, so that you can get access from that from there. Actually, I suppose if this is the one, I could put it in the chat. And then we meet to discuss every second Monday of the month. And so if you join the Google group, that you'll get reminders about the meeting coming up and the link to join the meeting. Okay, so what do we have? Is there something in the chat that we need to discuss? All right. I think those are just some good messages, so no questions. So at this point, I think what we'll do is we will ask to pause the session and we can go to the lounge. I'm not planning on coming back here. We may make an announcement if there's something we wanted to say, but otherwise we're probably not planning on coming back here. We'll just see you in the tables in the lounge. Thank you so much.